So this video is for solving radical equations. This is the video for Thursday. There is a Khan Academy video, but in the video he kind of goes into quadratic formula, which you can use on these, but I think I'm just going to show you some factoring just because I think it's easier. And I think like when he's doing some of his steps, he kind of skips and just assumes you know some stuff, like especially when he's foiling out some of the binomials, it gets a little weird. So what you're going to do is you're going to try to get rid of the radical, right? So to get rid of the radical, what we're going to do is we're going to square both sides. So if I square both sides, what I get on the right side of the equation is just x minus 8. But on the left, what we're going to have to do, unfortunately, is we are going to have to FOIL this guy out, okay? And I think in the video, he just kind of skips and just tells you what it is. But, and yeah, he doesn't do a good job of explaining every time. Anyway, so 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times positive 2x is a negative 2x. And negative 1 times negative 1 is a positive 1. Okay, I kind of squeeze that in there. So what I'm left with is 4x minus 4x squared minus 4x plus 1 equals 8 minus x. All right, so now you might be looking at this and saying to yourself, okay, how are we going to solve for x? There's a bunch of x's. Whenever you have a square term, okay, whenever you have a square term, odds are, especially in Algebra 2, you're going to try and move everything to one side and factor it. So if I move this 8 to the other side, okay, and I move this x to the other side, okay, we get 4x squared minus 3x minus 7. Okay, so now we have a quadratic set equal to 0. So what he does in the video is he uses the quadratic formula. So if you want to check out that video, you can, to sort of see what to do with the quadratic formula, but I am going to factor to solve. So if I'm looking at my quadratic, I have a, let's see, that's a highlighter. I have a being a number other than 1. So unfortunately what I'm going to have to do is I'm going to have to factor using a times c. Okay, so my a is 4, my c is negative 7, sorry. So my factors of negative 28 that add up to my b term, or negative 3, is actually our a and our c. So if we multiply 4 and a negative 7, we get our b term. So what I'm going to do is I'm going to break up this quadratic and make it a polynomial, make it 4 terms, using the positive 4 from our factor and using the negative 7. Sorry, not from our factor, from our work over here. Okay, I'm just rewriting the trinomial as a polynomial. Okay, so now what I can do, since there's 4 terms, is I can factor by grouping. So look for a GCF here, which is 4x. Okay, look for a GCF here, which is negative 7. Okay, and just like we've been talking about all year, I know that I'm doing this the right way because both of the things in the parentheses are the same, which means I've found the correct GCF. I'm on the right track. And what did I just do here? Let's try and, there we go. Okay, I'm just trying to move this along. There we go. Okay, so now what I have to do is I am going to, there we go. I am going to complete factoring by grouping by taking the GCFs that we found. Okay, putting them in a parenthesis. Okay, the GCFs that we found, I put in the first parenthesis, then I put the x plus 1 in the second parenthesis. Now, we just say what x values would give us 0 here. So over here, we already know, we can just look at this and say that would give us a negative 1. Over here, we might have to just solve a quick equation and just say, okay, 4x minus 7 equals 0. 4x equals a positive 7, x equals 7 over 4, just by solving a quick equation set equal to 0. So we have our 2 zeros. Unfortunately, And this is the thing for today. This is the main thing for today. you have to check. Okay, you have to check for extraneous solutions. So again, extraneous solutions are just solutions that algebraically work, but then when we go back and check it, it doesn't actually work. And the reason that happens is because of the square root in the original problem. Okay, the square root that's happening in your original problem, the x minus 8 underneath the radical. So if I'm going to check for my extraneous solutions, let's do that over here. So first what I'm going to do is I'm going to check, let's do it in, there's not too many colors here, which is, you know. All right, so if I check -1 into my original equation, so my original equation being 2x minus 1 equaling the square root of 8 minus x. If I put -1 into that equation, I'm going to get -2 minus 1 equals the square root of 8 minus a -1, which gives me -3 equals the square root of 9. Okay. Unfortunately, okay, when we're taking the square root of 9, they're asking for the principal root. So that does not work. This guy is not a solution. That is called what that is called a extraneous solution. Over here, let's just make sure this guy's good. If I'm putting 7/4 into the original problem, okay, I want to check and make sure that this works. So I'm going to get 14/4 minus 1 equals the square root of, and what I'm going to do underneath the radical, I'm just going to try to do this pretty quickly. I'm going to take this expression and just quickly make them both the same denominator so I can add them together. So I would get 32/4 minus 7/4. So what I did was I just put the 8/1 multiplied by 4 on the bottom and the top to get my new fraction. So what I have is 14/4 minus 1 equaling the square root of, let's see, 32 minus 7 is going to be 25/4. Hopefully I'm not running out of room here. Oh boy. I have to keep moving just that. That's weird. There we go. Okay. All right. So let's try to finish this up quickly here. I would get 5/2 as my principal square root of 25/4. And over here, if I make them common denominators, I would get 14/4 minus 4/4, which would give me, let me just kind of do this up here. It would give you 10/4 equals 5/2. Are they equal to each other? Yes, they are. That is good. So that means that x equals 7/4. Okay, we checked it and that works out. Okay, that is correct. Okay, next, another example is if you have two square roots, and this one's way easier because if you have two square roots, what you can do is when you square both sides, okay, the radicals just go away, and I'm left with x squared plus 6 equals -5x. Okay, again, just like in the one before this, we see this square term, and we say to ourselves, okay, this is a quadratic. Let's move everything to one side, so I get x squared plus 5x plus 6 equals 0. So all I've done is I've just added 5x on both sides of the equation, okay, to give us the x squared plus 5x plus 6. Now I say to myself, okay, it's a quadratic. The a term is 1, which means I don't have to do the a times c thing. You can, it will work out still, but you don't have to. So all I have to do is say, what are my factors of c that add up to b? So what are the factors of 6? Okay, what are the factors of positive 6 that add up to positive 5? And that would be 3 and 2. Okay, so now I'm just going to go and write it as x plus 3, x plus 2. Okay, using the two factors that I found that were factors of 6 and add it up to my b term. So now I just say to myself, okay, well, what would give me 0 in this first binomial? It would be x equals -3. Over here, it would give me x equals -2. Okay. We do have to check for extraneous solutions for this one. So if I'm looking at -3, let's do that in blue. If I put -3 into the original equation, I would get 9 plus 6 under the square root equals the square root of 15. Okay, does the square root of 15 equal the square root of 15? Yes, it does, which means this guy is good. All right, that is it. That is a solution. Let's try -2. So -2, I'm going to do it over here. If I put -2 into the original equation, I would get the square root of 4 plus 6 equals the square root of 10. Does the square root of 10 equal the square root of 10? Yes, it does. This guy is also good. So you actually get 2 solutions for this one. There are no extraneous for this problem. Okay, last example problem. Let's try and get rid of this radical by squaring. And again, if we square on the right side, we're going to have to FOIL. So on the left, we just get x squared minus x minus 2. On the right, we're going to get x minus 2 times x minus 2. Which gives us x squared minus x minus 2 equals x squared minus 2x minus 2x plus 4. So I get x squared minus x minus 2 equals x squared minus 4x plus 4. Now what I'm going to do is I'm going to try to move everything to one side of the equation. Me personally, I just like to move things to the left. But it really doesn't matter. You can do whatever you want. So I get x squared minus x minus 6 equals x squared minus 4x. Let's give me more room here. Scroll down. Okay, next I'm going to add the 4x. And just to save time for this video, I'm going to also subtract the x squared. Okay, just kind of doing it all in one step here. But we're just really combining like terms. The x squareds actually cancel out. That'll give us 0, okay, which we don't really have to write. But just to make you aware, that would just be 0. Negative 1x plus 4x would give me 3x. Okay, and now, since the x squareds cancel out, actually this is just a nice, easy problem. If it wasn't, you would just either have to factor or use the quadratic formula. But for us, if we're trying to solve for x, we would add 6 on both sides. Okay, and I get x equals 2. We just have to go back and check this guy in the original problem. So if I'm looking at the original problem, does 2 work out? So if I'm checking it, okay, I'll do it in blue over here. I would get the square root of 4 minus 2 equals 2 minus 2. So the square root of 4 minus 2 is the square root of 0. Does the square root of 0 equal 0? Yes, it does. This is good. That's not a check. That's a check. Okay. Which means there are no extraneous solutions for this guy either. Okay. So try the Khan Academy assignment. You can use his video if you want as well. But again, I think he doesn't do a great job of remembering that most of you guys, have some gaps in your Algebra 1 stuff, either from what you learned or maybe just what you remember. Okay, so I will post this. I'm actually going to post this. I guess when you see this, this will be, last night, but it's Wednesday right now. I'm just going to post it tonight, and hopefully Google can process it by tomorrow morning. Either way, we'll figure it out. Okay, I'll talk to you guys soon.